Hello, Professor. We are Team 15, and this is for our Project 1. The team consists of Zhen Rong, myself, Clifford, George, Wei Ren, Solomon, and Stephen. Okay, thank you, guys. So, today we'll be sharing about the application overview, the application design, the software engineering process, the software architecture, and lastly, the conclusion. So, I'll start off with talking about the application overview. So our application is a mobile game similar to the Hole-in-the-Wall TV show, where the player have to match the post to fit through the moving wall cutouts. So in order to play the game, it requires two players. One will be the director, the other one will be the performer. So the director will be the one holding the phone and giving verbal instruction for the performer to pose, and the performer will be standing in front of the camera and he will try to read the instruction and try to match the pose accordingly. So the game will start with 3 health, and every time the player matches the pose successfully, they will gain points, and if they don't match it, they will lose a health. Once all their health is gone, the game is over and the score will be shown. Now Zhen Rong will be sharing more about the design of the application.
Thank you, Clifford. So now I'll briefly go through the screens that we have set up for the game. So starting off starting off from the home screen, we have this bright green button for us to tap on to bring us to the game. Players can also tap the how to play button for reading the instructions, tapping on high scores to view the online leaderboard as well as their personal progress, tap on settings to adjust the volume or change their username. And last but not least, tap on credits to view the app developers, which is basically us. So now moving on to the game screen itself, where the game actually occurs. So at any point during the game, players are also able to tap on this pause button situated at the top right hand corner of the screen. From there, it will open up this pause overlay. Players are able to either resume the game from where they have left off, restart the game to start from the beginning, or return to the main menu. Then after the game has finished by losing all 3 lives, players are then being brought to this game over overlay where they are shown their final score as well as their top 5 scores on this first tab here. Players are also able to tap on the online leaderboard to view the online rankings if they are feeling a bit competitive. Otherwise, they can also retry the game or return to the main menu. So now I'll pass on the time to Stephen to talk more about the audio.
Thank you, Zhen Rong. So for our audio system, we decided to go with Soundpool for playing short sound effects and Media Player for longer musical tracks, which are eternal libraries of Android. And for the adjustable volume settings, we decided to put them in a singleton instance so that it is able to be consistently used by the project. As for the design choice, we decided to go with upbeat and energetic music and sound effects to fit the casual and fun atmosphere of the game. Next, I'll pass it on to Wei Ren.
So, thank you, Stephen. Next, I'll be talking about software engineering process. So first, we'll be talking about some of the libraries we'll be using. So first will be MLKit. So MLKit is used for our pose detection for our game. Scene view to render our game. Camera X, which is Android's default camera handling, which allows for permissions for cameras. Next is Firebase, a database that allows us for a leaderboard, so that allows for competitive play between players. Jetpack Compose, Kotlin's modern UI library that allows us to design the game as we wish to. Media, which is Android's default library for media and audio, so we can integrate some audio to make the game more lively. And last, it accompanies Google's utility for camera permissions. So next, we'll be handing over to Solomon to talk about advanced features.
Thanks, Wei Ren. So now I'll be talking about some of the advanced features my team has implemented. So first feature we'll talk about is the collision detection with bitmap. So how it works is we are using alpha values from a bitmap image, and where 3D pose images are mapped to a 2D cutout image. So the player's success is determined if there were enough landmarks which falls within the transparent areas. So the second feature that we'd like to talk about would be the exponential smoothing we have done on the landmarks, where it aims to reduce jitteriness by averaging the current and previous landmark position. So we have used a smoothing factor of 0.9 for optimal responsiveness responsiveness and stability. And this was the formula used. Next, I'll hand over my time to George, where he will share more about the software architecture.
Thank you, Solomon. So this is what our architecture looks like in a nutshell. At the top of the hierarchy is the main activity, which is the entry point of our game. Next are the home and the game screens, which contain the main menu and the game respectively. Okay, so the next it will be like these three blocks over here, because after the game screen you just go into this screen if you have permissions. And the game screen is composed of three components: the scene view, which handles the rendering of the walls and the player model; the game UI, which draws the background as well as any other text or overlays; and Android view, which works behind the scenes to provide scene view with the necessary information to render the player correctly. We did not use an ECS as we felt that it was overkill for our small project. The scene view library creates entities as nodes, which can be given properties such as size, shape, and material. To ensure that we have access to these nodes, we injected our onFrame update class to the scene view as well as the with permissions screen compose functions. And basically telling scene view to call the invoke method of our class every frame. So next is the Android view compose function, which launches the camera and passes the feed to the pose analyzer. Inside the factory parameter of the Android view function, we built a pose analyzer object, which is inherited from Android's image analysis.analyzer interface. So we then pass the information from the camera to the pose analyzer via the camera controller. So due to the inheritance, we are forced to implement the analyze function, which takes in an image proxy object. The analyze function launches a coroutine that sends the image proxy to MLKit for processing 90 times a second. When a pose is detected, the MLKit will send the on success callback that we have provided via another dependency injection, as you can see over here. This function is injected at a scope which also has a reference to the onFrame update object, as you can see over like this scope. So you'll be able to set its pose variable in this class to the one given by MLKit. Using dependency injection, we were able to pass variables around without messing up the control flow. Now I will go over the conclusion. So what went right and what went wrong? We learned what libraries can be used for 3D/AR rendering and ML tasks, and learned how to integrate libraries in Kotlin using Gradle. We also figured out a way to accurately implement player wall collision tests without using complicated or expensive collision algorithms. Lastly, we figured out a way to improve the player experience by smoothing the player model movement and centering it on the screen, which is something even the MLKit demo program didn't do. So what went wrong? We did not use a view model to separate the data from the UI, and this made the passing of information a bit cumbersome at times. So this is because we only learn about view models after we have implemented a rough architecture for our game, and it was too troublesome to refactor the entire code base. Next, some of us found it hard to test the game without an Android device, as physical modules like the webcam and audio player were much worse than on a typical Android phone. Lastly, the UI and frame rate on the emulator sometimes doesn't match an actual phone's, so we had to spend more time readjusting magic values like the weight and size of the widgets. Thank you for listening to our presentation.